Hello, welcome to part 2 of the practice test. So this is the calculator section. Here I'm asking you to simplify an expression with a bunch of exponents. What I would do is I would simplify the inside first. So here I'd have x y cubed over 5. Because if you think about it, those go away, that goes away, that goes away, and that becomes 3, that goes away, and that becomes 5. So that's why you get xy cubed over 5 cubed. Now I'm going to distribute the exponents. x3, y9, 5 cubed, x negative 2, y negative 6, 5 negative 2. Now when you're multiplying, you want to add the exponents. So you get x to the 1 power, y to the 3. That was a 5 negative 2, by the way. 5 to the 1. So it's xy cubed over 5. Number 2 is asking about end behavior. Remember, f of x is like y. When x is going towards negative infinity, that's going to be the left end. What's going towards positive infinity, that's going to be the right end. So if you look at part A, so this is how we're going to do this. The degree is even. The leading coefficient is negative, so both arrows have to point down. That means that y is going to always be pointing towards negative infinity, regardless if you're on the left end or the right end. Now here, for part B, the degree is odd. The leading coefficient is still negative. That means that we expect the arrows to be up then down. They got to go in opposite directions because the negative leading coefficient is always going to be, it's like it's going downhill. So what we expect to write for this one, f of x, as x approaches, so y is obviously going to be approaching positive infinity for the left end, because you have that right there, and negative infinity for the right end, because we're pointing down when x is going towards the right. So that's how you do parts A and B for number 2. Number 3. Write upon the function standard form of least degree rational coefficient, leading coefficient 1, that has the following zeros. So if you want rational coefficients, no radicals, and no imaginary numbers. So if we think about it, if you have negative root 2 as a 0, so is root 2. 3 minus 2i, so is 3 plus 2i. So these are your additional zeros. So if you write it, you write as x plus root 2, x minus root 2, x minus 3 minus 2i, x minus 3 plus 2i, and then you just work it all out. A better way would be just to imagine that x equals plus or minus root 2. So when you square both sides, x squared equals 2, x squared minus 2 equals 0. Also, x equals 3 plus or minus 2i, subtract the 3, then square both sides, you end up getting 4i squared, which I know is negative 4. So x squared minus 6x plus 13 equals 0. Now you want to FOIL x squared minus 2, or multiply x squared minus 2 minus 6x plus 13. So you get x4 minus 6x cubed plus 13x squared minus 2x squared plus 12x minus 26. So altogether we get x4 minus 6x cubed plus 11x squared plus 12x minus 26. Number 4 we've seen for the cardboard problem. Actually, this is straight from the Google Docs question. So say that's 10, and say that's 12. Cut out corners. X, 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 X. Then when you make your box will look like this. So it'll be x, 10 minus 2x, and 12 minus 2x. The volume is this. You graph it. The graph should look something like this. 0, 5, and 6. If you want the max volume, which happens right there. So remember, after you graph, graphing in calculator, find max by second trace max. So we find that at that point we'll be at 1.81, 96.77. So the maximum volume is 96.77 cubic inches. Your dimensions will be 12 minus 2 times 1.81 for your length, 10 minus 2 times 1.81 for your width, and you also will have 1.1 for your height. So if I get my calculator, so I have to go grab it, give me one sec here. So you get a 8.38 and 6.38. So the dimensions are 8.38 inches by 6.38 inches by 1.81 inches. And that pretty much concludes the video for the practice test. Good luck studying.